Yeah, I wonder how loud it was.
Yeah. All right, we're going to do area of composite figures today. So not any new figures, but just putting shapes together. And what's a composite figure is your first definition. So we are on lesson 9.3. 9.3, a composite figure, and I will put a couple composite figures on tomorrow's quiz. Composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. So we're going to have something that's a little more complicated picture, but we're going to see if we can divide it into simple shapes. Triangles, rectangles, circles, trapezoids. I would say a hexagon is probably not a simple shape. But we're going to try and get it to match up as close as possible to all those shapes. And circles, you could do part of a circle. Like, how would you figure the area of half a circle?
Find the area of the whole circle and divide it by 1/2, or multiply by 1.
Yeah, multiply by 1/2 or divide by 2. So yeah, find the area of the whole thing and divide it by 2. As you are working through something that maybe needs half a circle, it probably would help you get it right if you're writing down half circle rather than just circle. So that you're thinking about, I need to divide it and only use part of it. So really what we're doing today is the area addition postulate. If you remember when the tangram puzzle was up there, you find the area of every separate piece. When you put it together, the area of the whole thing will be the total of all those areas. Some of our areas we will add, there will be some where we subtract in order to come up with it. Which way is easiest or best really depends upon what the shape looks like. So here's our first one. And my circles in that are a little bit distorted. Again, this projector is pulling it in from the sides, making it skinnier so it's a little off. But I think you can still figure out what's going on. It says find the shaded area, round to the nearest tenth if necessary. So now I did dash across there so that you can better see how much of a circle do we have? Half. And I'm not going to try and trick you, so for the most part there will be some dots there. If it's not there, you're assuming that's half. It's not that it's off of the center. So that is half of a circle, and then trapezoid. If you don't think a trapezoid is simple enough, you could divide it into at least a rectangle and a triangle. If you wanted to divide it right there, you could come up with 3 areas to add instead of just 2. So you decide if you want to divide it there or if you want to just do the whole trapezoid together. I'd like you to work on trying to find the area of this first one. We'll go to the nearest tenth, but try and hold off as long as you can as far as rounding. Okay, so find the area of the circle that you want half of it. Is the 20 millimeters the radius or diameter? The diameter. If it's the radius, it would probably be just pushed over to the side, show you just what half of it is. circle? Half a circle was 50 pi. Now, I didn't even put in the 3.14 yet. I'm gonna wait till the end. And I think I broke it into a triangle and a rectangle, but we can add together and see what you're. My triangle was 84, my rectangle was 280. So if you did the trapezoid and you had the trapezoid of those together, that would be 364 for the trapezoid. Okay, so add 364 plus 50 times pi, which is like about 150-ish. So the total should be 521.1. Some I was looking at, you were agreeing, but I think you must have both made the same mistake, not doing half of a circle, or some that were bigger. Question on that one? Somebody got that right. What was the error not doing half a circle? All right, that seems to be the most common error on problems like this. So write down, as I said, maybe write down 1/2 circle rather than just circle. Okay, let's try this shape. How should we divide it up so we can find the area? Because initially you see a lot of triangles. But if we try the triangles, let me just clarify, I think you're going to have trouble finding the base lengths of the separate little triangles. If it were an isosceles triangle somewhere, then it's a midpoint for the base, but not on these. So yeah, how can we group it differently?
On the top parallelogram and then the bigger triangle.
Okay, so I think you're kind of dividing here. This top part has opposite sides parallelogram. And the bottom is a triangle. The way that this 10 is kind of centered on that side, they're telling you this whole length is 10, not just one part of it. You have to kind of see where they position the measurements. A parallelogram plus a triangle. Total? Shown there already. The parallelogram is just base times height. So you could use the 8 for the base of the parallelogram. The perpendicular does go all the way to the other side, so that would be your height. So the parallelogram is just 8 times 5. The triangle is 1/2 10 times 5. And then adding 40 and 25, 65 is the answer. How many got that one right? Quite a few. Any question? Okay, let's find another picture. Find the area of the shaded region. How can you divide it, and can you find the measurements you need? But sometimes you might want to divide it a certain way, but you can't figure out what the measurements are. Question, or are you done? have to find a measurement, but you can figure it out. Or maybe even more than one measurement technically. Which way are you dividing it? Vertical or horizontal? Vertical. So right there. Making a right triangle and a rectangle would be the intention. Something else. If you're stuck, could you get the rectangle? 37.5 by 22.5? Okay, then the triangle, we intend it to be a right triangle. Now, if this whole base is 75 meters, and then this part was your 37.5, you can subtract and find the other part. So 75 minus 37.5 happens to also be 37.5. So that'll be the base of your triangle. The height of the triangle can be found by doing the Pythagorean theorem. Correct. Height comes out to be 50, should be the height. So if you got 50 for the height, the area of the triangle then would be 1/2 times 37.5 times 50. You're adding those two together. So the total was 1,781.3. There's 10. You have a question coming up with that? Getting them figured out. All right, next one then.
Oh, you have to subtract it.
So this time, so you're subtracting what?
Area of half a circle.
Okay, area of half a circle. You're not subtracting a whole circle. All right, so figure out the area of the triangle and the area of the circle, and you do want to subtract that half circle, not a whole circle. Yeah, we're cutting it away instead of adding it on.
if I did that?
Make sure you're subtracting half of a circle, not a whole circle. Okay, so my triangle was 234. The half circle, I haven't multiplied by pi yet, so if I did, it would be like 30 something. Half of a circle is what you're subtracting. I'm gonna subtract it, not add it. It's not a bubble on the outside of the triangle, it's part of it away. So I had 202.2. So those that had, let's see, 170 something, is that what you get when you subtract the whole circle away? Okay. So that was the common mistake, that was fine. Any more comments or clarifying on that triangle situation? No? Okay. How about the next shape? Can you tell which parts are shaded?
5 times.
Okay, the whole circle was shaded, but then the trapezoid is out of there. Okay, so circle could be used to start with, and then you're gonna take away or subtract out the area of the trapezoid. Okay, let's see if you can arrive at the right answer. You want a whole circle or half a circle? This time with you. Really, you should work with hundredths and then again round to tenths. As I mentioned, you should be working with at least hundredths and then rounding to tenths. But if you can keep it in terms of pi and wait till the very end, that would be a little bit more accurate. Any more answers you want me to look at? Okay, the answer should have been, was 186.2. Clarifying completed. Add the bases. So add the largest one. Is that 128? All right, next shape. It's a bit distorted in the picture there. Well, what is that shape?
If it's in a circle, it'd be a square.
You have a way to prove that?
Some theorem in a piece of paper in my folder.
I don't think we have that. I don't think we have a theorem that says if there's a shape.
Well, how
inside-
is it wrong? And that means like it would be a little skinnier and then the circle would be an oval.
Wait, is
All
it
the
an
sides
oval?
are the same.
Or is it supposed to be?
All sides are
It's,
equal.
Yeah,
both
it's a
sides are
square.
So it's at least a rhombus.
It's
Right. Maybe would have to work a little bit on trying to determine whether it really is a square or not, but at least it's a rhombus. And I agree with your thinking that, it will end up being a square. I just don't think we have the theorems to support it yet.
I don't know.
is it a circle?
Seems like something would
Yes,
go
it's supposed to be a circle, it looks kind of oblong.
Oh, well, that makes sense.
If those touch it,
If they're congruent, then
the
they
diagonals would have to be the same color and the same order.
Okay, so if you think of the two diameters, they'd both be equal, which would give it the rectangle qualities. So I suppose that could be one way we could support it being a square. We will have a theorem that helps us determine what those angles are. It is a square, but I don't know what formula would you use to find the area of it if you are doing it as a square?
oh, 1/2 times
Oh,
D
one
times
half.
D2, D1 times. That one.
If you use it as a rhombus, you use the diagonals. I don't know if you think of it as a square, you'd probably be searching for what the side length is. So actually, it's easier if we think of it as a rhombus. Because 1/2 diagonal 1 times diagonal 2, what's the other diagonal going to be? The way it's positioned in there, it would also be 6. I know it's distorted up there, but 6 and 6 would be your diagonals because of them being diameters of that circle. Okay, so let's think of it just as a circle minus a rhombus. Circle's area is the 6th, the radius or diameter. Diameter, so be careful. Radius is 3. 9.5 for the circle. Minus how much for the rhombus square thing?
Wait, how do you find that?
If you think of it as a rhombus, it's 1/2 diagonal 1 times diagonal 2. The other diagonal would also be 6. Sorry, maybe the decimal might be off. Was it 3/8?
I got 2/7.
Okay, I think I had .3. Are you using?
I have 10
Okay, why are you on 3/8? What's your circle? I don't know. Yeah, let's read it and see what you're doing that's different. Okay, we got 10.3s back there? Okay, you correct. Okay, next one.
So you can
Company,
draw a circle.
the company receives an order for 65 pieces of fabric in that shape. Each piece is to be dyed red, and to dye 6 square inches of fabric, we need 2 ounces of dye. You need a lot of dye to make it really red. So how much dye is needed for the entire order? That's what we need to figure out. So what multiple steps do we need to do?
Well,
Find the area of that.
is it square?
Is it a square there?
Is the inside a square?
Yes.
Yes. Or it could be a kite.
We don't
Yeah, I
know.
guess it could be.
Could be a kite. What do I need to put on there to clarify? I intended it to be a square. I probably need to put some more 3s maybe to clarify. Okay, I meant it to be a square. Or do what? Or put more right angles in there, that could work also. Okay, so I can do that real easy. Okay, so this is supposed to be a right angle also, and this is supposed to be a right angle. That's enough now to, that's a square? Okay, now it's a square. Okay, so we're gonna do a square plus
Guys, it's 9.
half circle and half circle. You have to do them separately? No, you can think of it together. So a square and a circle added to find that area, then we have to go on. Let's do that much. So find the area of that one. Let's see. 1.5 is the radius. I have, that would be 0.6. Yeah, I guess I didn't add my 9 onto it yet with that decimal. Okay, what are you getting for the area of that?
16 to 20.
And how accurate are we gonna go? We're not at the end of the problem.
16.07.
So I would be going 2 decimals. 16.07 is what I should have used anyway. Okay, let's make sure that that's what I did. Okay, 16.07, my right angles are still here. Okay, then what do we need to do? Let me go back to the problem. Well, wait, not divide by 6 probably yet. How many of those do we need to make?
65.
65, so multiply that area times 65. So that's how much we need to dye.
It's a big number.
Okay, now how much dye do we need? For every 6 square inches of fabric, we need 2 ounces of dye. So you've got like 174?
Yeah.
144?
I think on the end.
Alright, so divide by 6 to see how many groupings of 6 I need, like how many batches we have to dye. And multiply by 2 ounces.
Oh, wait, no.
So how much dye do we
I'm
need?
sticking with my answer.
Okay, let me see what that number is. I was just looking at somebody's work. Maybe they didn't have the right number. Okay, so that times 65, yeah, was 1,044.55. Okay, I definitely said the wrong number looking at someone's. Okay, so then we divided that by 6 to see how many batches we need to dye.
Yeah.
Okay, a little over 174 batches, and we need 2 ounces for every batch that we're dyeing. So we need about 348.18 ounces of dye. Should have made you turn that into like gallons or something.
You should not change it.
Alright, there were enough steps involved there.
Or change it for next year.
Change it for next time.
Yeah.
Alright, any questions on the process? You know, I would say that you should multiply by the 65 before you divide by the 6. Because if you took the area of one of these and divided it into 6 square inches, I think you would be tempted to round that. And then when you multiply by 65, I think you're going to arrive at a different answer. Okay, how about a weird shape like this? How can you find the area of it?
It's at least 1 square.
And every square, yeah, we're gonna treat as like one square inch or 1 square
This is
whatever.
impossible.
Now, we're not gonna get an exact area, we're gonna estimate as close as we can. When you do calculus, you're gonna have techniques that will get more accurate than what we're gonna do right here.
8.
But it leaves it up. Yeah, kind of half.
I think it's 8. It's about 8.
One huge square, like in the middle, you mean? Okay, she's thinking 1 huge square. Is that big enough? So 2 by 2, that has an area of 4.
Yeah.
Okay, now what?
5, 6, 7,
3
8.
triangles, so you want this to be a triangle?
It's 8.
Is that a close approximation?
Good
Yeah,
enough.
we cut a little bit off. So that is area of
Oh no.
1. It's a triangle with a base of 2 and a height of 1. You wanted this as a triangle?
Let's make that a hexagon.
Area is 1.
I mean,
This side you want to make a
as
triangle?
long as we're guesstimating.
You want to go all the way to that?
No.
Make like
Just make 2 triangles.
little.
Okay, now let's hear what I heard Jenica say is, yes, that's going beyond it, but that
It's
space
making
might
it.
make up for the extra that you have here. Now, you cut some off here, so that could fill in part of this. Is it perfect? No, but I think that would be reasonable. Now, how about the top section there?
It's just like 1.75. We just
One
had
almost, want to do a trapezoid?
Yeah.
Trapezoid as in across here and diagonal there. So then we've got a little here to allow for something again that we had cut off. So what's this area?
1 times 2 times 1.
Okay, 2 plus 1 would be the bases.
What I
Times 1
said
for the
made no
height.
sense to me.
1/2 for the trapezoid. So 1.5 total.
Yeah.
And you can look at that and say, okay, that square is 1.5 more. So we came up with 4, 5, 6, 7, 8.5. Now, I will usually give a range on these, and I thought that you would come up with like 8 to 9, so 8.5. I would say you're not gonna go any more fractional than a half. If you're doing something more exact, you're really not estimating. So do the best you can to position your shapes. And I know this is easier if you have like the graph paper to draw on it. So I'm sure that probably someone has drawn in your books, but maybe erase that or the ones that I have on like a worksheet or on the quiz or test, you'll be able to draw on those easily. How would you maybe do this one?
Do a big rectangle.
Do a big rectangle,
Like,
like you mean from here all the way to the bottom
sure,
and all the way across?
why not?
I like cut off two.
Cut off two, stop here?
Oh,
Okay, so it's suggested I stop there. Go all the way to the corner?
yeah,
Okay, now, is that too much?
no, no.
Kind of depends what we do for the rest. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 there.
And then we've got a 9. We've got one single one right there.
Triangle out of this,
Yeah. Sure,
like here and here. Okay?
that'd be like 2.
2 by 2, and it's a triangle.
Maybe 2.
2.
2 times 2 is a half. Still 2.
You want to make that into a triangle, like going on down?
I was just gonna, no, just
Trapezoid, you think would be
the
better?
square.
So you want to go diagonal,
You guys see
here,
it.
diagonal? Better than just one triangle?
Then do a right triangle.
So 1, 2, 3 plus 1, that's 4 times 1,
It's 2 again.
okay, and a half.
And the last one's big triangle.
And then that's,
One great big triangle?
Yeah.
Trapezoid?
No.
No, you think triangle would be better?
and that makes up for all the extra that we've left off.
So that maybe helps with that. Okay, so this would be an area of
Like,
1, because the
One-ish.
base is 1, the height is 1. So 1 total for that. So there's 10, 11, 12, 13.
Wait, isn't that
13 to 14.
What?
different?
Height's 1.
So I thought 13 to 14, you came up with 13. So
Okay.
if we had done a trapezoid here, it would have been 13 and a half.
So smart.
So approximate as close as you can what those are. All right, did I have any more?
Oh.
Kind of looks like a camel or something, huh?
I don't know, I want to write that. 4, 5.
Okay, you try and estimate. I know it's kind of hard to do without the shape there. That's what you think?
Yeah.
Boom. That's
I
the
said
answer.
5.5.
That's the fight.
Okay. Some of you are
Oh,
showing
you
me. Now,
labeled yours.
make a decision, which number you want to give me.
5.4.
Okay, I'm seeing what, any others want to get in here?
Oh, I got this. That's my ratio.
All right, I'm trying to look. I think there's
1
more,
to 100.
there's more giving me 5.5.
Oh, 5.4.
I had around 5. Some of you are going 6, 6.5. That's getting a little higher. I think I saw 6 to 7. That's a little high.
Way too high.
Now, 5 1/4, you're maybe not estimating, but I probably wouldn't look at something more than a half as far as accuracy. So around 5 for that one. 1, 2, 3. Thought that was kind of fair.
5.164.
Maybe 5.5. I might look at that one again. 5.3.
5.3 is right.
Okay, so we had weird shapes. Would you do this one by adding or subtracting?
What did
No,
you
but
write?
you would do.
The area of the shaded region.
I subtract.
Probably add
I don't know.
triangle, rectangle, half a circle. How would you do this one?
Under trapezoid.
Okay, I think some are saying add. I think this might be more of a subtract. It could be done either way. Okay, if you're adding, you're probably doing rectangle, skinny trapezoid, added together. If you're doing a subtraction, subtraction, you'd probably treat it as a great big rectangle, and then the area of the white trapezoid subtracted away. Could you figure out the measurements on that white trapezoid?
Yeah,
Probably
9 minus 1
I'm
and
sure
1.
someone can do it.
So this would be 7 for the base. The height is half of that, so 4. Yeah, we can get the measurements figured out. I would probably subtract on that one if I were you. And then here's
Come on,
another
Mike.
story problem. How would you find the area of the shape? Probably 2 rectangles. And that would be the multiple steps where you've got how much it costs. So you have to get the area. What's the area? We can do this one quick. This one has an area of 12.
Let's see,
12 there also.
6 times 2 is, it's still 12.
So 24 square
Math
feet
has-
times 2.7.
times $2.70 for every square foot is how much?
Hello.
64.8? Let me see what the answer was. 64.80, yes, was the answer.
Did we ever get a math problem?
So that one wasn't as involved. Okay, and a weird shape again.
Oh, I'm gonna do this one. 1, 2, 3, 4, 5, 6, 7, 8.
All right, you can do that while I'm putting the assignment.
It's
All
like
right.
8 to 11.
We do have some time for you. You can get started on the assignment or research your mathematician a little bit more. Some of you started that yesterday.
There's like no information about my guy. He worked with whatever, what's it called? Quadratic formula. That's all it says. Like 50 times on all the websites I can help you with. He did stuff with quadratic formulas.
Is that because what
Oh, so we know like what? His name? It has math written on his tombstone. That's all we know.
It's like, so how much?
Oh, it's like 9.5. It's like 9.
Oh!
That's what the program told me, 8.5. So you think that's a little low?
Program.
You think more like 9?
It's like
I'm not sure if it's not due to
All right.